Students, what we're talking about here is the start of this video series is how to solve systems of equations. Now I'm going to give you kind of a simple example to start with, and that is, let's think of all the pairs of numbers that add up to 5. The sum of two numbers is 5. And we can write that in equation form as x plus y equals 5. Well, right away I can think of 2 and 3, I can think of 1 and 4, I can think of 6 and -1, and so on. So obviously there's more than one pair of answers for x and y. Alright, so that has multiple solutions. But when I pair it with the other idea, and that is the difference of two numbers is 3, or x minus y is 3, I could come up with and sort of guess and check a little bit and come up with a pair of numbers that add up to 5 and subtract to give you 3. Okay, that's basically what a simultaneous or a system of equations is, a solution set for more than one equation. Well, let's go ahead and do our job here with graphing. Okay, this is a simple example again, but if I graph all the pairs of numbers that add up to 5, I can say 1 and 4, I can say 2 and 3, I can say 3 and 2, I can say 4 and 1, 5 and 0, 0 and 5, and so on. So now I can make a straight line and I can extend it to go throughout the graph, and this will be my solution set for all the points where they add up to 5. So every point on that line would solve that equation, x plus y equals 5. Alright, now at the same time, simultaneously, I want to know the answers to this one, x minus y is 3. Now in a previous video I talked about the cover-up method, which would give me an x-intercept of positive 3 and a y-intercept of negative 3. Now I won't go into the details here, but basically you cover up the x to find the y-intercept, you cover up the y to find the x-intercept. But that gives me 2 points that I can connect and make a line out of. So if x-intercept is positive 3, the y-intercept is negative 3, now let's make a line out of that. And there you go. That's the solution set of both equations, and notice how they do intersect. So in simultaneous equations or systems of equations, if there is a solution that solves both, that'll be where the lines intersect. Now if I look at this, it'll be 4 and 1, 4 comma 1. Now what we're going to do is just double check that. Does 4 plus 1 equal 5? Yes, it does. Does 4 minus 1 equal 3? Yes, it does. So that is the solution set of that system of equations. Alright, number 1, the first equation, y equals x plus 1. Now that's in slope-intercept form already. So if it says x plus 1, that means the slope is positive 1 and the y-intercept is positive 1. So that will give me a line that looks like this. That will be our first solution. Alright, the next one, let's go ahead and find the y-intercept is negative 2. So we're going to put a dot there. And the slope is positive 4 over 1. So we're going to go over 1 up 4. And you know, it looks like that's our solution right there. Let's put another dot there at the same slope, and then we can go down 4 and over 1. And let's go ahead and draw our line. So the line would look similar to this right here. Alright, so solution is right here. And what we think it looks like is positive 1, positive 2. Now the thing you should do is definitely check it in both. So does 2 equal 1 plus 1? Substituting my x and my y value in there. And does 2 equal 4 times 1 minus 2. Yes, it does. So both work. That's the solution to the system. Now you try the next one. All right, in the first equation, notice that the slope is -3/2 and the y-intercept is -4. All right, so that would be this line right here. From -4, we go over 2, up 3, over 2, up 3, and so on. In the other one, we have y equals 1/4 x plus 3, and that will be a positive slope of 1/4 and a y-intercept of 3. So there's your y-intercept, and it's a 1/4 slope, so go over 4, up 1, or over 4, down 1. And the intersection, of course, is that point, which happens to be -4, +2. Now, if you substitute that x value, -4, and that y value, +2, into both equations, it will work. All right, I have 2 more for you to try. All right, numbers 3 and 4, those are in standard form, so you can use the cover-up method to find the x and y intercept, or you can use some algebra and write it in slope-intercept form. That's up to you. But go ahead, in a few seconds I'll show you the answers. All right, number 3, x plus y equals -2. Now if I cover up the x value, that will give me a y-intercept of -2. So that is why I have that dot right there. If I cover up the y value, then x-intercept is -2. And so I would have a dot there. And then I connect the dots to make my line there. Now this line is x equals 2. That means everywhere along the line, the x value is always +2, and the y value goes up or down and can be anything. So that is that vertical line right there. Well, obviously they intercept, if we draw our graph accurately, at +2, -4. Now if you substitute that in there, x is +2. Yep, definitely +2. It doesn't matter what y is in that second equation. But if I substitute my x and y values there, I will get -2. So that point solves both equations. And number 4, x plus y equals 4. That means I have an x-intercept of +4 and a y-intercept of +4 if I cover up my x and y terms alternately. In this one, I'm going to end up with a x-intercept of -1/2 and a y-intercept of +1. Or I could rewrite it in slope-intercept form. And I get that line, and that is my intersection point, which is +1, +3. All right, so we're solving a system of equations by graphing. Thanks for watching, and look for the next video in this series. It is about substitution. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard,